In this video, we're going to talk about balancing chemical equations in 2 steps. Okay, let's go. Okay, so the first step is to count the number of each type of atom on each side of the chemical equation. So let's have this equation. H2 plus O2 will yield H2O. So to make it easier or clearer, you need to make a table. Then you have to divide this into the reactant side, the product side. So count the number of each type of atom on each side. So here you have 2 hydrogen atoms, and here you have 2 oxygen atoms. On the product side, you have 2, and oxygen you have 1. As you can see, the hydrogens are balanced. So now let's try to balance the oxygen. For the oxygen, you have 2 here, so you need to multiply 2 here. But don't forget to put it in the coefficient. This will give us 2. Now they are balanced, but since you put 2 here, you need to multiply 2 to the number of hydrogens. So 2. This will give us 4 hydrogens. The number of hydrogens now are unbalanced. So to make it balanced, you need to multiply 2 on the product side. This will give us 4. Okay, so write 2 here. Now we can say that the equation is balanced, since the oxygen and the hydrogen atoms on each side are balanced.
I do not want to comment.
So the first step is to count the number of each type of atom on each side of the chemical equations. For example, we have the synthesis of nitrogen dioxide. So it's better to make a table to organize your data. So again, you have the reactant side and the product side. So let's count the number of nitrogen in the reactant side. For N, you have 1. For oxygen, you have 1 plus 2, we have 3. Now let's go to the product side. In the product, you have 1 nitrogen plus 2 oxygen. Now we're going to change the coefficient. The coefficients are the numbers found before the chemical symbol. You can find the coefficients here. The numbers after the chemical symbols are called the subscripts. If a chemical formula doesn't have a subscript, automatically it has 1 a subscript. So 1, 1. But again, we don't write the number 1. So the technique here in changing the coefficient is to change the coefficient of a diatomic molecule last. Okay,
Academy Award.
so diatomic molecule is O2. So you will change its coefficient last. Okay, so recall the diatomic molecules. We have no fear of ice cold beer.
What are you thinking? Spell it!
It stands for hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. Now let's try to change the coefficient. Since we have 2 oxygens here and we have 1 here, we will change this one. To balance the oxygen, we'll put 2 here. But in doing this, we will also change the number of nitrogen. This means that we have to multiply this by 2. To make it clearer, I will divide the oxygen. So oxygen 1 is this one. Oxygen 2 is this. Okay. So multiply 2 to oxygen 1, we will have 2. And for oxygen 2, we still have 2. Okay. So now the oxygen here are balanced, but the nitrogen here became 2. So to balance this, we need to put 2 here. Okay, so times 2 will have 2. And you have to multiply this by 2 also. So this will be times 2. We will have 4. Now let's check if the coefficients are balanced. So you have 2 nitrogen, 2, 2. So they are balanced. For the number of oxygen you have, in the reactant side, you have 4 oxygens. In the product side, you have 4 oxygens. So now we can say that the equation is balanced. So remember that this is a synthesis reaction.
And so we're not going to have that, okay?